everyone. In this particular session, we will discuss K-neighbors learning and let us try to understand the concept behind it. Here you can see the algorithm itself is K-neighbors. That means we need to identify certain number of neighbors over here. So let us try to understand that how this algorithm actually works. This neighbors algorithm is a supervised learning algorithm. So you can understand that we need a data set which is having the input data as well as labels along with it. So input and output both should be present. This actually works on classification as well as regression. For classification purpose, if you see, we need to go for maximum voting, and for classification we can also go for weighted voting. Now this maximum voting is, for example, let's say if we have an input and this input is basically can be a cat or can be a dog. So we are trying to match this input with existing input output pairs. And we found that this cat or dog input output pair data, out of them, three cats are matching with the input and one dog is also matching with the input. So, to which one should we basically give the output? We should give the output as cat because more of the cats are similar to the input data. This is called as maximum voting. Sometimes we need to do weighted voting as well. Another thing is when we have to do regression, in that particular case, we take the average or we take the weighted average. So that is the logic or mathematics which is behind K-neighbors learning. Here you can see that we have status as fail or pass, and then we have input data as score 1 and score 2. Now looking at the score 1 and score 2, the status is determined. So 10 and 15, they basically come up as fail. 15 and 20, they basically contribute or they result as pass. 30 and 12, they result as pass. Now we have a new input. Here you can see we have a new input which is yes. So the new input is 29 and 14. So this is the new input. And we don't know whether with this score the individual is pass or fail. So this neighbors algorithm is going to check that which are the neighbors nearer to 29 and 14. So if you try to calculate the distance, 10 and 15, how much nearer they are, 15 and 20, how much nearer they are, and 30 and 20, 12, how much nearer they are to 29 and 14. So let's assume that 10 and 15 are the farthest one, 15 and 20 is nearer, 30 and 12 are most nearest. So now the two nearest neighbor are 15, 20 and 30 and 12. For 15, 20 we have the output as pass. For 30 and 12 also we have output as pass. So if for both of them the output is pass, then what we will do? The maximum voting says 2 votes for pass and 1 vote for fail. And therefore I will give this question mark a value as pass. This is called as maximum voting. Let us now move ahead and try to understand the next slide. Here if you see, we are working on distances. Distances basically, here you can see that 1.5, 1.9, 2.4, 1.6. So distances from 29, 14, okay, with respect to all other data points. And there we saw that it is more nearer to, let's say, pass. And therefore we will give the output as pass. So this is how the neighbors get identified, and we give a token or an output to that particular label, and that could be either pass or fail. But what if the data output is continuous? In that particular case, we will find the average. We'll see that which are the nearer ones. Let's say we want two nearer neighbors. That is also something we will decide. How many neighbors do we want? So if we are planning for two neighbors, then what is happening? Here we see that this one and this one, 2 and 1. these are the nearer ones. So if these are the nearer ones, what we will do, we will take the status average 17.5 plus 21 divide by 2, that is 19.25. That is the status for 29 and 14. Let's move ahead. So here if you see that whenever we are having some data points represented like this and we want to compute their distances. So how to compute the distances? Because if you have some data point which is like in a number line. So in this particular case, if some data point is here, another data point is here, simply the value you can get is 3 minus 2 and we are getting the value as 1. That is the output. But if some data point is like this in 2 dimension, then it has got two coordinates, x and y coordinate. Then how the distance will get computed? If I do something like this, x2 minus x1 plus y2 minus y1, what will happen? Sometimes it will be something like this, 5 minus 4 plus 4 minus 5, which is 1 plus minus 1, which is 0. So in order to not getting into this kind of situation, what we can do, instead of taking the actual differences, we can take absolute differences. So take absolute differences, and then the output which you are getting is 2. So this 2 is Manhattan distance. Now another way is, instead of taking the absolutes, here we have taken absolute values, we can take squares. If you do square, it becomes Euclidean distance and you get the squared output. Okay, and at the end you are doing 1 by 2, underrooting it. Let us move ahead and try to understand the next one. So the next one is generic one, where what you can do is, so this is Euclidean, this one is generic one, where you can put p over here, generic. So now if you put 1, it becomes Minkowski. If you put 2, it becomes Euclidean. And if you are putting it as just p, then it is Minkowski. So Euclidean and the Manhattan, they both are special cases of Minkowski. They are both special cases of Minkowski. So this is what is K nearest neighbor algorithm. Finds out the nearest neighbors and accordingly it tries to predict that whether the given output is belonging to this particular class. I hope you enjoyed this particular video. Let's get on to the practicals. Thank you.